boiling are both processes where a liquid turns into a gas, but they have distinct differences. Let's explore what sets them apart and why it matters. Evaporation is a surface-level process that occurs at any temperature as long as molecules at the surface of the liquid gain enough energy to escape into the air. Evaporation happens gradually and doesn't require the liquid to reach its boiling point. It's how water in a puddle or clothes on a line dry over time. Boiling, on the other hand, occurs throughout the entire liquid once it reaches its boiling point. This is when the vapor pressure of the liquid equals the atmospheric pressure, allowing bubbles of vapor to form within the liquid. Boiling happens rapidly, as seen when water boils on a stove. Why does this difference matter? Knowing the distinction helps us understand energy transfer. Boiling requires additional heat to reach the boiling point, while evaporation absorbs energy from the surroundings, causing cooling. This is why sweating cools us down. The evaporation of sweat draws heat away from our skin. In summary, evaporation is a gradual surface process that occurs at any temperature, while boiling is a rapid process at a specific temperature throughout the liquid. Understanding these processes is essential for fields like cooking, climate science, and even health.
There are several key differences between evaporation and boiling. So in this video, we'll look at the differences between evaporation and boiling, and then we'll look at a few of the similarities. So let's start off with the kind of obvious. For evaporation, there aren't bubbles. So we just have a beaker of water here. It's evaporating, but we really don't see much happening. There aren't any bubbles. For boiling, though, there are bubbles, and they form throughout the liquid. So we have bubbles forming in the bottom, the sides, and near the top. So one difference that we can see right away is that evaporation, we don't have bubbling or boiling, we have bubbles throughout the liquid. This kind of leads to our second point, is that evaporation, it only takes place on the surface of the liquid. So in our beaker here, water molecules are leaving the beaker, but they're only leaving from the surface. That's the only place they can really get out. Evaporation takes place at the surface of the liquid. In contrast, boiling, it takes place throughout the liquid. So when we see those bubbles forming, those bubbles are full of water molecules in a gaseous form. So there's steam. So the water has been converted from a liquid to a gas all throughout the beaker of boiling water. We should also note that evaporation, it's a slower process. It doesn't take place very quickly. This beaker of water could take days, maybe a week or so, to evaporate, for it all to change from liquid to gas. But boiling's a much faster process. So we add that energy, makes the water molecules leave more quickly, and this beaker of water here could be gone in a few hours. Another difference is that for evaporation, it occurs at any temperature. As long as we have a liquid, evaporation can take place. And even when we have a solid, we can have water molecules leave the surface. We just call that sublimation instead of evaporation. For boiling, there's a very specific temperature, and we call that the boiling point. So water, for instance, at standard pressure, water, it's going to boil at 100 degrees Celsius. When we hit 100 degrees Celsius at standard pressure, that's when water starts boiling. Something like ethanol, that'll boil at a lower temperature, 78.4 degrees Celsius. That's when it starts boiling. So evaporation occurs at any temperature, and that temperature can fluctuate with the surroundings. As it gets warmer or colder, evaporation still will take place. For boiling, once we hit, say, that 100 degrees with water at standard pressure, the temperature remains constant. It doesn't get any hotter. So water won't boil higher than 100 degrees Celsius. The only way you can make it boil at a higher temperature is to put it under pressure, like a pressure cooker. So with boiling, once we hit our boiling point, the temperature won't go up anymore. It'll remain constant. Finally, when something's evaporating, the energy comes from the surroundings. That's what gives us the energy to make those water molecules change from a liquid to a gas. But with boiling, since we need more energy, we have to use an external source, something like a flame from a Bunsen burner. And as we put that energy in, once we reach the boiling point, 100 degrees Celsius for water, then it starts boiling, but the temperature doesn't go up. It still remains constant. It stays at 100 degrees Celsius until all the water's gone. So those are the big differences between evaporation and boiling. Let's talk about some similarities. The main similarities are that both involve liquids changing into gases. They also both need energy to take place, either from the surroundings or from an external source. And they're both physical changes.